I'm going to work through both examples on this second page in the notes in one video because they make use of the same trig identity. And they're going to make use of one of the ones that was listed under case 3 on the previous page. And it's the fact that sine squared is equal to 1 minus cosine 2x over 2. So I'm going to use that here in the first one. It says integrate from 0 to pi 8 sine to the 4th x dx. So that sine to the 4th is just sine squared squared. And we can rewrite that. And I'll replace the sine squared x with the 1 minus cosine 2x over 2. So I'm going to multiply that out, and I'm left with 8 times 1 minus 2 cosine 2x plus cosine squared 2x all over 4 So then we have the 8 in front. It's just waiting to help us get rid of that denominator. Of course, 4 goes into 8 twice. So now I can distribute the 2, and that gives me the integral. We're going to integrate from 0 to pi. And we've got 2 minus 4 cosine 2x plus 2 cosine squared 2x dx. Now, the first 2 terms are ready to go. We can integrate them right now. That third one, we are going to need to use a trig identity one more time. So what I'm going to do is I'm going to break this down into 3 separate integrals. So I've got 0 to pi 2 dx minus 0 to pi 4 cosine 2x dx. And then that last one, instead of writing the cosine squared 2x, I am going to use the similar identity to what I have here. The only difference is that there's going to be a plus instead of the minus. So it's going to be 1 plus cosine. Now I need to double my angle. So instead of a 2x, we're going to have a 4x over 2. And that allows those 2's to cancel out. So now I am ready to go. I can integrate this thing across the board. For the first one, when I integrate 2, I'm just left with 2x, and we'll evaluate that from 0 to pi. Here, cosine 2x, remember it's going to be cosine 2x times 2 dx, because you would need to have the derivative of that 2x as well. So it's going to be minus 2. Okay, so from that 4 there, 2 of them goes to the derivative of the 2x. So we just have 2 left over. It's going to be minus 2 times negative sine. No, it's not. It's positive sine, 2x. Sorry about that. My brain is thinking of this negative here. And we're going to evaluate from 0 to pi. Then down here at the end, we've got 1 plus cosine 4x. That 1 just turns into an x. The cosine 4x Again, we would need a 4 for the derivative of the 4x. Since I don't have that, I can bring it in by introducing a 1/4 in front. So I'm going to have plus 1/4 sine of 4x. And again, we're evaluating from 0 to pi. So the first one, we've got 2 times pi minus 2 times 0. So that's 2 pi minus 0. Then here I've got the negative 2 in front. Sine of 2 times pi is going to be 0. Sine of 2 times 0, sine of 0 is also 0. So we get a big fat 0 there for that second one. Then over here, I've got pi plus 1/4 sine of 4 pi. Well, sine of 4 pi is 0, so 1/4 times 0 is 0, so it just leaves me with a pi. Minus 0. Again here, plugging in a 0 for x. Sine of 4 times 0, sine of 0 is still 0. So we've got pi minus 0. Not sure why I've got parentheses and brackets there, but it's okay. So after all of this, what are we left with? We're simply left with 2 pi plus pi. Everything else goes to 0, so we have 3 pi in total. So there we're using the different trig identity with sine squared being equal to 1 minus cosine of 2x over 2, and then we did the same thing with the cosine squared later on. You don't always have to use these identities more than once inside these integrals. So the second example here, we're going to make use of the same trig identity, but we're only going to need to replace things once here. So here I've got the square root of 1 minus cosine x over 2 inside the integral, and we're integrating this one from 0 to 2 pi. So one more time, let me write down what that trig identity was. It said sine squared of x is equal to 1 minus cosine 2x over 2. So here, the angle with the cosine is double that of what's with the sine. So if you look here, I don't have a cosine 2x, I just have a cosine x. When I go ahead and use this identity to replace it with the sine squared, it's going to be half this. So I'm going to replace the 1 minus cosine x over 2 with sine squared of x over 2. So I have the square root of sine squared x over 2. Again, I've got these extra parentheses in here that I don't really need. Dx. I've got the square root and I'm squaring it. They're going to cancel each other out. So all I'm left with is sine of x over 2. And this is going to be very straightforward to integrate. Again, remember, I need the derivative of the x over 2, which would be just a 1/2. I don't currently have a 1/2, but I can introduce it inside if I bring a positive 2 on the outside. So if we bring that 2 outside, we can go ahead, well, it would look like this. It's going to straight integrate it, but this is what we have, because I alluded to this in the previous example. So now I can integrate. When you integrate sine, you get negative cosine. So I've got negative cosine of x over 2, and we are evaluating that from 0 to 2 pi. Now, we're starting with the 2 pi. 2 pi over 2 obviously is just pi. Cosine of pi is negative 1. Negative negative 1 is positive 1. Then minus. Cosine of 0 over 2 is cosine of 0. Cosine of 0 is positive 1, but we've got a negative, so it's going to be 1 minus negative 1. So 1 minus negative 1 is going to give me a 2 inside the parentheses. 2 times 2 is just 4.